Hello, welcome to Engineer's Mindset. So today I'm going to take us through first principle differentiation. So I'm going to show you how to differentiate from first principle. Now let's say that y is equal to x. Okay, so I'm asked to find dy dx from first principle. Okay, so if y is equal to x, here is z. Okay, I'm going to increase y by change in y. So if I increase y by change in y, I will also increase x by change in x. So this simply implies x plus change in x. While change in y and change in x actually means what? Increment in y and increment in x. So a little increase in the value of y will cause a corresponding increase in the value of x. So I simply have this. Now at this point, I will simply send y over to this side of the equation. So I will be left with change in y at this point of the equation. So I have that change in y is now equal to x plus change in x. Now if I send y over to this side, y here is positive. Positive plus and equal to sign, it becomes negative. So I will simply have minus y. Okay, now but from the question, recall that y is actually equal to what? X. Y is equal to x. So which means in place of y, I will simply replace what? X. So that means that change in y is now equal to, this is x, plus change in x. In place of y, I will simply say what? Minus x, because y is equal to x. So I simply have minus x. So if I collect like terms, I'm going to have change in y is equal to, so let me bring all the x terms together. So I'll simply have x minus x plus change in x. So x minus x is off at 0, therefore change in y equals change in x. Okay, so I will divide both sides. Since the equation says find dy dx, so which means I have to divide both sides by change in x. So I will obtain change in y over change in x. So I'm simply going to have that change in y over change in x is equal to change in x over change in x. Okay, so that means change in y over change in x is now equal to change in x over change in x simply gives me 1. Now, the limit as change in x tends to 0, which means wherever I see change in x in the equation above, I should simply replace it as what? 0. Now this function, change in y over change in x, will actually tend to what is called dy dx. So therefore, dy dx is simply equal to what? 1. So these are the transformed to what? Dy dx equal to 1. Okay, so that is how you can evaluate differentiation from first principle. So let's try another example and see what we are going to obtain. Let's say that y is equal to x squared, and we are asked to find dy dx from first principle. So just like in the first case, if I increase y by changing y plus change in y, I'm also going to increase x by changing x. So I'll have x plus change in x. But remember that x here has the power of what? 2. So that means I also have to what? Square this to what? Power 2. Okay? Okay, so we now have to what? Expand this bracket x plus change in x. Okay, so we have y plus change in y is now equal to, this is x plus change in x. Since it's squared, so we'll have times x plus change in x. So y plus change in y is now equal to, so I will expand this bracket. So let me use x to expand this bracket. X times x gives me x squared plus x times change in x gives me x change in x plus change in x times x is also x change in x plus change in x times change in x simply gives me plus change in x squared. So I have this. So y plus change in y is now equal to x squared plus this is x change in x plus x change in x simply will give me 2x change in x plus change in x squared. So having known this, at this point what to do is simply what? Send y over to this side of the equation so that change in y will remain below here. So I'll simply have change in y is equal to, this is x squared plus 2x change in x plus change in x squared. Now this is positive y. If positive y crosses an equal to sign, it becomes negative. So I'll simply have minus y. Okay, but from the question, recall that y is equal to x squared. So recall that y is equal to x squared. So it means now that wherever I see y in this equation, simply replace it with x squared. So I'm simply going to have change in y is now equal to, this is x squared plus 2x change in x plus change in x squared. Now in place of y, I'll simply replace it with x squared. So it becomes minus x squared. So let's collect like terms together. I'm going to have that change in y is equal to x squared. I have x squared here minus x squared, so bring them together. Minus x squared plus 2x change in x plus change in x all squared. So at this point, x squared minus x squared is off. So I have change in y is now equal to, this becomes 2x change in x plus change in x all squared. So I have this. Now, what you do at this point is simply divide both sides by what? Change in x. So you divide both sides by change in x. So I will simply have change in y over change in x is now equal to, this is 2x change in x plus change in x squared. Okay, so this is 2x change in x all over change in x plus change in x squared all over change in x. So you have this, okay? So change in y over change in x is now equal to, so change in x cancels change in x, so this is off. I simply have 2x, okay? Plus here we have change in x squared, so one of these cancels one of these change in x. So I'm left with plus change in x. So at this point, now consider the limit as change in x tends to 0. So that simply means that if I consider that change in x is equal to 0, then the function change in y over change in x will automatically become dy over dx. So wherever I see change in x, I will simply plug in the value as what? 0. And if that happens, then change in y over change in x automatically becomes dy over dx. So which means this function here is not to be replaced as what? 0, because we have change in x here. Alright, so I'm going to now have dy over dx is now equal to 2x plus, in place of that change in x, simply call it 0. So that simply means that dy dx is equal to 2x. Alright guys, so I will see you in the next video with more questions on first principle differentiation. In the meantime, I'm sure you like this video. Do well to subscribe and of course invite your friends who are not subscribers. Share your thoughts in the comment section. I would like to hear from you.